In this lesson, we will develop and discuss the concept of improper integrals. What is an improper integrals? What is improper about certain integrals? What is the process of integration? Integration is a method of measuring the area enclosed by the graph of the function with the x-axis. Is that right? Now, an improper integral is particularly associated with a definite integral. For example, you want to find the integral of integral 0 to, say, e ln x dx. Now, what is improper about it? Let's draw the graph of this. Now, the graph of ln x will be something like this. Is that right? Now, is this function defined at x equal to 0? As x gets closer and closer to 0 from the right, the function value goes to negative infinity. So, if you want to find the area enclosed by the graph of this from 0 to e, it's sort of an improper exercise. It is not very proper. So this is an improper integral. How about integral 0 to infinity of e to the power of negative x? Now, how about the graph of e to the power of negative x? E to the power of negative x, the graph goes that way. So, if I want to measure the area enclosed by the graph of this function, from 0 to infinity, the graph never touches a point on the x-axis. So, how do we measure the area enclosed by the graph with the x-axis? It is an improper integral. So, an improper integral is actually an integral that has, say, infinity as one of the limits, or at one of the limits the function is undefined. For example, if I want integral 0 to 2 of square root 4 minus x squared, what is improper about this? Well, at x equal to 2, well, this is okay. Let me just rewrite it as 1 over square root 4 minus x squared. Well, at x equal to 2, the denominator becomes 0 and the function becomes undefined. So this is an improper integral. So you have several types of improper integrals. We're going to look at these kind of integrals and how to evaluate them. A method to evaluate such improper integrals, and that's what we will discuss today. So one form of an improper integral is a definite integral where both limits, one or both limits of the integration is infinite. Now, for example, integral 0 to infinity f of x dx is an improper integral. Integral negative infinity to 2 f of x dx is an improper integral. Integral negative infinity to positive infinity f of x dx is an improper integral. Well, now, will an improper integral yield a definite value? Well, some of them do. So, if an improper integral yields a definite value, then it is called a converging improper integral. That type of improper integrals will converge to a particular value. In other words, that improper integral has a definite value. But some others don't have a definite value, and such integrals are called diverging improper integrals. So improper integrals can be converging or diverging, and we will test some of these integrals for convergence or divergence. Now, how about this? We talked about this. integral 0 to e ln x dx, is that an improper integral? If so, why? Well, you notice that this function is not defined for x equal to 0. Alright, now in order to evaluate an improper integral, we are going to develop a method. Now, if f of x is continuous on the interval a to infinity, there's no break in the function, then integral a to infinity f of x dx can be written as limit b approaches infinity, integral a to b f of x dx. In other words, the limit infinity is replaced by a finite number b, and then we take that b and take the limit of that when b goes to infinity. Take the limit of the value of that integral when b goes to infinity. We know the skill of taking the limit of functions, so we will use that in here. Similarly, if f of x is continuous on the interval negative infinity to b, then integral negative infinity to b f of x dx will be limit a approaches infinity, integral a to b of f of x dx. In other words, we replace that negative infinity by a, and after evaluating the integral, we will take the limit of that when a goes to negative infinity. That's the method. Alright, another one. If f of x is continuous on negative infinity to positive infinity, then we've got to break the improper integral into two pieces. We would say this is the same as integral negative infinity to c f of x dx plus integral c to infinity f of x dx. That's not difficult to understand. We want to measure the area enclosed by the graph of this with the x-axis from negative infinity to positive infinity. So first we measure the area from negative infinity to c, and then we measure it from c to infinity and add them together. There is no problem in that. Now each of these is an improper integral, and we can evaluate that using limit forms like this. So how do we write this? This will be limit a approaches negative infinity, a to c of f of x dx, plus, how will this become a limit? Limit b approaches infinity, integral c to infinity, well, c to b, we have replaced that infinity by b, so it should read limit b approaches infinity, integral c to b f of x dx. So these are some of the methods that we'll employ in evaluating such improper integrals. Okay. Alright, now we had talked about this actually in the last class. What is limit x approaches infinity e to the power of negative x? We talked about that. Limit x approaches infinity e to the power of negative x. Remember, e to the power of negative x is 1 over e to the power of x. And 1 over e to the power of x when x goes to infinity is 1 over e to the power of infinity, which is 0. So this limit is 0. There you go. Which is the same as limit 1 over e to the power of positive x, and that will be 0 when x goes to infinity. The value of that will be 0. Alright, let's now find the value of an improper integral. Now, why is this improper? You can see one of the limits is infinity. Integral 0 to infinity e to the power of negative x dx. In other words, what is the area enclosed by the graph of e to the power of negative x with the x-axis from 0 to infinity? Alright, you know how to find that integral, is that right? First of all, we will write this as a limit. What will that look like? integral 0 to infinity e to the negative x dx will be limit b goes to infinity, integral 0 to b of e to the negative x dx. And you know what integral of e to the negative x dx is. What is it? It is negative e to the power of negative x. That's right. Integral of e to the power of negative x dx is negative e to the power of negative x. And the limit is from 0 to b. And we take the limit of this quantity as b approaches infinity. Alright, let's apply the upper limit minus the lower limit. So this will be limit b approaches infinity, negative e to the power of negative b minus the lower limit is negative e to the power of 0. Alright, now what is limit b goes to infinity e to the power of negative b? E to the power of negative b as b goes to infinity is 0. So this value is 0. So we will end up with negative, negative, positive. E to the power of 0 is 1. So that will be limit b approaches infinity, negative e to the power of negative b plus 1. And you know this already. Limit b approaches infinity, e to the power of negative b is 0. So the value of this will be 0 plus 1. That's equal to 1. The value of this improper integral is 1. Is this a converging improper integral or a diverging improper integral? Well, it is a converging improper integral. That area converges to 1. Alright, another one. Evaluate the improper integral, integral 0 to infinity, x e to the power of negative x dx. Well, there are two things I want you to look at it and figure out. One, write it as a limit. Second, how do you integrate this? X e to the power of negative x dx. Which of the integration techniques we developed so far will apply here? Well, think about it. First of all, integral 0 to infinity x e to the power of negative x dx, write it as a limit, is limit b approaches infinity, integral 0 to b of x e to the power of negative x dx. And we will use the table method. Is that right? We have done several of those earlier. So the table method, where u is our x and dv is e to the negative x dx. Is that right? So our u, dv, u is our x, dv is e to the power of negative x dx. And find the derivative of u continuously until you reach 0. Derivative of 1, x is 1. And the integral of e to the negative x is negative e to the negative x. So I hope you remember, find the derivative of u continuously and find the integral of dv continuously. Alright, what will be the next step that you have? Derivative of 1 is 0, integral of negative e to the negative x will be, what's integral of negative e to the negative x? Is positive e to the negative x. So you have 0 e to the negative x. Now we stop there and we can now pick our answers by assigning these signs: positive, negative, positive. We don't need anything for the 0. So in that integral, the first term is, what's the first term? Negative x e to the negative x is the first term, minus e to the negative x is the second term. So we will have in here limit b approaches infinity. The value of that integral is negative x e to the power of negative x minus e to the power of negative x. limit from 0 to b. We can now apply that limit. Set x equal to b, the upper limit, then minus set x equal to 0. When x equal to b, you have negative b e to the power of negative b minus e to the power of negative b. This is for the upper limit. Then minus the lower limit. X equal to 0 gives you that 0 minus e to the power of 0. Okay, now tell me, we can factor out e to the power of negative b from here. So that will be limit b approaches infinity, e to the power of negative b comes out. You can actually take out a negative e to the power of negative b. A negative is common, e to the power of negative b comes out, leaving a b plus 1 here. And what is in here? That will be negative, negative, positive, e to the 0 is 1. Okay, what is limit b approaches infinity, e to the power of negative b? Well, that limit is 0. That will be 1 over e to the power of positive infinity. That will be 0. That will eliminate this term completely, leaving us simply the answer 1. So that will be 0 plus 1, which is 1. The value of this improper integral, integral 0 to infinity x e to the power of negative x dx, is 1, which means that it is a converging improper integral. Okay, another one. Evaluate the improper integral, integral 0 to infinity e to the power of negative ax sine bx dx. All right, if you cannot read this properly, just listen when I read it. Integral 0 to infinity e to the power of negative ax sine bx dx. What's the method for integrating this? Well, the same, integration by parts, isn't it? All right, you can choose this as your u and that as your dv. All right, let's do that. First of all, write this as a limit. Integral 0 to infinity e to the power of negative ax sine bx will be limit c approaches infinity. It doesn't matter what you call, whether it is b, a or c. I'm choosing c here because there is a b already here. I don't want to duplicate that. So this can be written as limit c approaches infinity, integral 0 to c. So our infinity has been replaced by c, and we let c approach infinity at the end. Integral 0 to c e to the power of negative ax sine bx dx. All right, we use the table method. Can't we use the table method there, or can we? Now the table method will not work there. Why not? Because the table method will work only if the quantity you choose as u will, when differentiated continuously, will reach 0. In this case, what happens? When you find the derivative of e to the power of negative ax, it will keep on revolving. Negative e to the power of negative a e to the power of negative x, a squared e to the power of negative x, negative a cube e to the power of negative x. It will probably roll over and over. Similarly, integrating sine bx dx will give you negative cos bx over b, negative sine bx over b squared. It will roll over. So you cannot use the table method here. So what we're going to do is we will use integration by parts repeatedly. We will use integration by parts twice. All right, let's now choose our u and the dv. Our u is e to the power of negative ax. Therefore, what is our du? Du is negative a e to the power of negative ax dx. Our dv is sine bx dx. And therefore, what is v equal to? V will be negative cos bx divided by b. If you cannot see this on the screen, take a note of those. Our dv is sine bx dx, and integrating that will give you v equal to negative cos bx over b. Alright, let's now write this integral. What will that be? We will have integral u dv is u times v minus integral v du. Now we're going to leave the limits out for the time being. We will go back and pick the limits once we finish with these steps. So we'll say integral 0 to c e to the negative ax sine bx can then be written as u times v. Look at that, u times v. This is negative e to the negative x times cos bx divided by b, u times v, minus integral 0 to c. Now remember, I said we will leave the limits. Now this is part of the integration. That means that limit actually applies to all this. So we're going to leave this for the time being. We will come back to that later. Minus integral 0 to c of v du. V is negative cos bx over b, and du is negative a e to the power of negative ax dx. And you can see there's a negative, that will make it positive, and that negative will remain as it is. So once again, it will be negative e to the power of negative ax cos bx over b minus. Now, there's an a on the numerator, if you notice, and a b on the denominator. We can factor that out. A over b comes out. Integral 0 to c. What is left in here is e to the power of negative ax times cos bx dx. That is what is left there. And you notice this is now an expression similar to the one that we started with. And so what we're going to do is we're going to take this and do integration by parts one more time. Alright, watch this carefully. This is an important type of problem. Okay, let's repeat integration by parts for this, where e to the power of negative ax is your u and cos bx dx is your dv. Alright, u equal to e to the power of negative ax. What's our du? Du is negative a e to the power of negative ax dx. Our dv is cos bx dx. Therefore, integrating will give you v equal to sine bx over b. And therefore, what will this integral be? Well, it will be u times v e to the negative ax sine bx divided by b minus integral v du. Alright, let's write that. So integral u dv is uv minus integral v du, and we will use this to work out this part. Everything else remains the same. So this will be negative e to the power of negative ax cos bx over b, that's that term, minus a over b times, we are now writing the terms for this integral, where we chose this equal to u, and that's our dv. So what is that integral equal to? A over b times u times v. U times v, the product of these two terms is this, minus integral 0 to c v du. So that will be sine bx over b, that is v, du is negative a e to the power of negative ax dx. Alright, let's do one more simplification then. Again, if you notice, an a over b can be brought out in here. Is that right? So it will be, that term will remain the same, no change there, minus a over b times, we're going to leave this the same. The change we have there is a over b has come out. There's something else that came out. If you notice, that negative sign becomes positive. How? We brought out that negative sign and that made this positive. That will be a over b came out. What is left there is e to the power of negative ax sine bx dx. Alright, now if you notice here, this is the original integral that we started with. So by doing integration by parts, we came back to the same integral we started with. So does that mean there is no end to this? Well, actually there is a beautiful way we can resolve this dilemma. Alright, let's see how it can be done. Now if you notice, this is the integral that we started with. Integral 0 to c sine, integral 0 to c e to the power of negative ax sine bx dx. This is the integral that we wanted to evaluate in the beginning. And that's what gave all these after doing integration by parts twice. And if you look, this term, integral 0 to c e to the negative ax sine bx dx, is exactly that one. We produced the same integral. Alright, so this is the left hand side and the right hand side is this whole thing. And let's simplify that right hand side by doing what? We can actually distribute this a over b into here. And I want you to watch this once again. This is the left hand side we started with. And all these things that we have been doing is the right hand side. So the first term on the right hand side is this. Negative e to the power of negative ax cos bx divided by b minus, let's distribute that, minus a over b. That gives you a e to the power of negative ax sine bx divided by b squared. Now, minus, because that's minus, and multiply this a over b with this a over b gives you a squared over b squared integral 0 to c e to the power of negative ax sine bx dx. Alright, now you can see I colored the left hand side and part of the right hand side red. Why did I do that? Well, because they are both the same. And so, what all we need to do is try and combine them. So what all we need to do is move this term, this whole term containing this, to the left hand side and combine them together. Let's do that. So what I did is, this is the left hand side there, and I moved negative a squared over b squared integral 0 to c e to the negative ax sine bx dx to the left hand side. It became positive a squared over b squared, the same integral. And now what's the right hand side? The right hand side will be now these two terms. So integral 0 to c e to the negative ax sine bx dx plus a squared over b squared integral 0 to c e to the negative ax sine bx dx, that is this term moved to the left, equal to these two terms, negative e to the power of negative ax cos bx over b minus a e to the power of negative ax sine bx over b squared. Alright, let's now go to the next page and try and simplify this. Now can you tell me how will you simplify the left hand side? Think about it. You can see on the left hand side this integral 0 to c e to the power of negative ax sine bx dx is common. We can pull it out. And what will be left? There will be a 1 left here plus an a squared plus b squared left here. You see how beautifully you can put it together into a single term there. Let's do that in the next page. So this is what we had, and we are going to now combine, in other words, factor out the integration part. There you go. So that will be integral 0 to c e to the power of negative ax sine bx dx is factored out. What is left in here will be a 1 plus what is left in here will be a squared over b squared. And that's equal to the right hand side. Can we simplify the right hand side? Yes, we can take b squared as the common denominator. When it does that, the numerator here will multiply by b. So you will get negative e to the power of negative ax b cos bx minus e to the power of negative ax a sine bx all over b squared. That became a single term. And what are we looking for? We are looking for this integral, isn't it? That is the quantity that we want to evaluate. And therefore, in order to find the value of this, what all we need to do is divide both sides by this quantity, 1 plus a squared over b squared. So, we have, first of all, let's simplify this one more time. Because 1 plus a squared over b squared is, again take b squared as the common denominator, is a squared plus b squared over b squared. So the integral remains the same and the right hand side has not changed. So to get the value of this integral, what do we do now? Well, divide by this quantity. And so we get integral 0 to c e to the power of negative ax sine bx dx equal to this divided by this. Is that right? Or when you divide by this, you simply reverse it and multiply. So that's what I've done. So the right hand side multiplied by the inverse of this times b squared over a squared plus b squared. Now b squared and b squared will cancel. There you go. And that gives you e to the power of negative ax divided by a squared plus b squared times b cos bx plus a sine bx. Now this is what this integral looks like. And now what we need to do is we need to take the limit when c goes to infinity. Is that right? Well, first of all, let's apply the upper and lower limit before we go to the limits. All right, let's do that here. So integral e to the power of negative ax sine bx dx equal to limit c approaches infinity. Is that right? We know that we want to find integral 0 to infinity e to the power of negative ax sine bx dx. That is the same as limit c approaches infinity of integral 0 to c e to the power of negative ax sine bx dx. And we have found the value of this definite integral. What is that? Is this. We can now replace this by this. That's right. So that will be limit c approaches infinity of that quantity. Now the lower limit is 0, the upper limit is c. So let's now apply the limits. Take the upper limit minus the lower limit. That will be limit c approaches infinity. Replace x by c, wherever you c and x, replace it by c for the upper limit. That's what I've done here. Minus, wherever you c and x, replace it by 0 there. So you got the replace x by the upper limit minus replace x by the lower limit. Okay, what does that yield you? We can do a number of simplification here. E to the power of 0 is 1. Cos 0 is, what's cos 0? Cos 0 is 1. And sine 0 is 0. Therefore, this term here will simply be negative 1 over a squared plus b squared times b plus 0. So this will simplify to, tell me what that will simplify to. This quantity will simply be b, and this is 1. So it will be negative b over a squared plus b squared, and the negative will combine to give you positive. So that will simply be b over a squared plus b squared. Alright, so what will this be now? In the limit when c goes to infinity, let's apply the limit here. In the limit when c goes to infinity, this is your c. What is e to the power of negative ac when c goes to infinity? The limiting value of this is 0. Because the limiting value of this is 0, it reduces the whole of this to 0. So the first parenthesis, the value is 0, that is the upper limit, minus now the lower limit, where this is 1 and this is 1, so this will be b plus 0, and that gives you b over a squared plus b squared is the value of that improper integral. You see how terrible looking improper integral gave you such beautiful result. Okay, so what we have produced is integral 0 to infinity e to the power of negative ax sine bx dx equal to b over a squared plus b squared. Is that a converging integral or a diverging integral? It is a converging integral. Alright, let's try another one. Evaluate the improper integral. Integral 0 to infinity e to the power of x over 1 plus e to the power of x dx. But again, there are two things I want you to think about before start doing it. First of all, we need to write this as a limit. Secondly, you need to think of a strategy of integrating it. Alright? Think about it. So, write this as a limit. Integral 0 to infinity e to the power of x divided by 1 plus e to the power of x dx is limit b goes to infinity, integral 0 to b of e to the power of x over 1 plus e to the power of x dx. Alright, I have actually given away a clue for you to do this now. I have colored the denominator red and e to the power of x dx in green. So what's the method of integration here? It's a simple substitution. What is a substitution? We substitute 1 plus e to the power of x equal to u and take the differential. The differential of the left hand side is e to the power of x dx equal to du. So when this becomes u, e to the power of x dx becomes du. I know this method must be now very familiar to you, and you must now feel very comfortable doing it. So this will be limit b approaches infinity, integral 0 to b. I warn you, this limit is for x, not for u. But we just carry it. Once we finish the integration, we can replace u by in terms of x, u bar this quantity, and then apply the limit. So this 0 to b does not apply to u, although you can say u is a function of x. Alright, now integral 1 over u du is ln of u. So that will be limit b goes to infinity ln u, and the limit goes from 0 to b. Remember, the limit goes from 0 to b for x. So we first of all replace u by 1 plus e to the power of x. So that will be limit b goes to infinity ln 1 plus e to the power of x from 0 to infinity. Alright, replace the upper limit. That will give you, when x is replaced by b, e to the power of b, what is limit b goes to infinity e to the power of b? Well, that is infinity. So the upper limit is ln infinity minus the lower limit is, when x is replaced by 0, e to the power of 0 is 1, 1 plus 1 is 2. So the upper limit is ln of 1 plus e to the power of infinity, which is ln e to the power of infinity, ln infinity minus ln 2. Now, do we have a proper value for that integral? No. Therefore, what kind of an integral is this? This is a diverging improper integral. That's right. Okay, another one. Determine if integral 0 to e ln x dx converges or diverges. Well, I think I gave it away already. I just showed it to you in the beginning of the class. Do you remember that? Alright, let's work with it. Integral 0 to e ln x dx can be written as, why is this improper anyway? Because ln x is undefined at x equal to 0. Therefore, we take the limit when b approaches 0. Is that right? So this is replaced as limit b approaches 0 integral b to e. I hope you understand how we take the limit. The limit is taken wherever either the function is not defined or there is an infinity for the limit. Here, at x equal to 0, the function is undefined. So we take the limit when b approaches that value. So this will be limit b approaches 0 integral b to e of ln x dx. Well, now you know how to integrate ln x dx. You use integration by parts. U is ln x, du is 1 over x dx. Our dv is dx, therefore our v is x. And what is that integral therefore? Integral u dv is u times v minus integral v du. So let's write that down. Limit b goes to b approaches 0, integral b to e of ln x dx now equal to limit b approaches 0. Now, what's the integral? U times v x ln x minus integral b to e v du x times 1 over dx, and x cancels. So that will be limit b approaches 0 x ln x minus x. Is that right? X ln x minus integral of x. This quantity will be integral of dx, which will be x. And the limit is for that whole quantity. So that will be x ln x minus x. Lower limit is b, the upper limit is e. Alright, we need to find the limit when b goes to 0. So first let's apply the limits. That will be limit b approaches 0, upper limit is e. So x ln e minus e minus the lower limit is B ln B minus B. Alright, now we take the limit. What is the value of the second parenthesis here when B approaches 0? Replace B by 0. When B is 0, this will go to 0. Therefore, the limit will simply be this. What is that value? What is ln of E? ln of E is 1. So this will be E minus E, and that will be 0. So the value of this improper integral is 0, and that means it is a converging improper integral. That's right. Okay, another one. Determine if integral 0 to 2 of 1 over square root 4 minus x squared dx converges or diverges. I had just showed it to you in the beginning of the class. Why is this improper? This is improper because at one of the limits, the function is undefined. When x equal to 2, the denominator becomes 0, the function is undefined. So this is an improper function. We need to take a limit. Say limit b approaches 2. Is that right? So we have a discontinuity at x equal to 2. We will write integral 0 to 2 1 over square root 4 minus x squared dx will be, how do you write this as a limit now? Will be limit b approaches 2 of integral 0 to b of that quantity. Alright, now, how do we integrate this? This is actually a standard integral you should be able to pick out quickly. This is of the form integral 1 over square root a squared minus u squared du, which is, alright, quickly, what's integral 1 over square root a squared minus u squared du? Is arc sine u over a, where u is x and a equal to 2, a squared minus u squared. Alright, so this integral is the arc sine form with a equal to 2 and u equal to x. 1 over square root a squared minus u squared du is arc sine u over a. Therefore, this will be limit b approaches 2 arc sine u over a, means x over 2, and the limits 0 to 2. Let's apply the upper limit and then the lower limit. That will be when b goes to, when b goes to 2, 0 to 2, arc sine of, when x equal to 2, it becomes arc sine 2 over 2, that is arc sine 1, minus, when x equal to 0, it is arc sine 0. Alright, what's the value of arc sine 1? Sine of what number is 1? Sine of pi by 2 is 1. And what is arc sine 0? Sine of 0 is 0. Therefore, arc sine 0 is 0. Therefore, this is pi by 2, this is 0. That means the value of this improper integral is pi by 2. The improper integral converges to pi by 2. Alright, let's do another one. A 5 metric ton rocket is fired from the surface of the Earth to outer space. What is the work done to overcome the Earth's gravitational force? Now, how far has the rocket traveled when half the total work has occurred? Now, you must understand that this is something that we have done earlier on in Unit 1 about work done when the force does not remain a constant. As the rocket lifts off from the Earth, the force changes. And we said the force changes according to what equation? F equal to K over R squared, where R is the distance of the rocket from the center of the Earth. So, if you have the Earth in here, that's your Earth, that's the center of the Earth. This distance is what we call the radius of the Earth, and the rocket is going to be lifted off from there. And at any time when the rocket is here, that distance is actually R, the distance of the rocket from the center of the Earth. So the force at any time will be K over R squared. Is that right? Now that's what actually that means. Let's write these things down now. Okay. Now, the weight of the rocket on the surface of the Earth. Now, remember, the force that needs to be applied to lift the rocket is its weight. So, what is the weight of the rocket on the surface of the Earth? The weight of the rocket on the surface of the Earth is its mass times the value of G on the surface of the Earth. And the mass is 5 metric tons. So its weight will be its mass times the value of G on the surface of the Earth. We can use it as 9.8 meter per second squared. So the weight of the rocket on the surface of the Earth is 5,000 kilogram times 9.8 meter per second squared. That is 49,000 Newton. And this weight will change as the distance increases according to the equation I just gave you. Weight will change as K over R squared. So using Newton's law, the weight of the rocket on the surface of the Earth can be written as F equal to K over R E squared. You see, if F equal to K over R squared, where R is any distance, but when the rocket is on the surface of the Earth, that distance is the radius of the Earth. And you know the value of the radius of the Earth. Now, we know the weight of the rocket on the surface of the Earth here. We know the radius of the Earth. Therefore, we can calculate that K. That is the first thing to do in this problem. And the radius of the Earth, you know, is 6.64 times 10 to the power 6 meter. And using F equal to 49,000 Newton and RE equal to this value, we can find the value of K. The advantage there is K doesn't change with altitude. What changes is the weight. F changes with the altitude. But K remains the same. Wherever you go, that K is the same. So once you find the value of K, we can use it anywhere as the rocket goes into space. So let's find the value of K by placing F equal to 49,000 and R equal to this value. And that gives you K equal to this big number, 49,000 times 6.64 times 10 to the 6, all raised to the power of 2. And that is 2.16 times 10 to the power 18. That is the value of K. Well, it has also a unit. In mathematics, we really don't consider much of that. Its unit will be Newton meter square. Newton meter square. Alright. Now, the work done to overcome the Earth's gravitational pull is given by, remember, what we are doing is we are taking this rocket from the surface of the Earth and away from it to infinity. So, the work done will be integral. The distance at the surface of the Earth is RE. And the distance when it goes to infinity will be infinite. So integral RE to infinity k over r squared dr, isn't it? The work done is the force multiplied by displacement. And because this force does not remain a constant throughout the displacement, we assume that this force remains a constant during the very small displacement dr. So we calculate that dw, the work done for that small displacement, and then integrate it from the surface of the earth all the way to infinity. The value of r on the surface of the earth is the radius of the earth. That's the meaning of this integral. And we know the value of k, so we will now write this as a limit. This is the integral. This is an improper integral because that limit is infinity. So that integral now is w equal to limit b approaches infinity, integral re to b k over r squared dr. What is the integral of k over r squared dr? It is negative k over r, and the lower limit is re, the upper limit is b, and if you apply that, apply the upper limit, it will be negative k over b, that's the upper limit, minus negative k over re. That's right. Yes, and now tell me, what is the value of k over b when b goes to infinity? In the limit when b goes to infinity, k over b is 0. Any number divided by infinity is 0. So this will be 0, minus become positive. So this will be k over r, 0 plus k over r. And k we know, r we know, and that gives you the total work done to take this rocket from the surface of the earth and put it away from the earth. That means the rocket will never come back. It has gone completely out from the gravitational field. The total work done is 3.25 times 10 to the 11 joules. That means this is an improper integral that converges to this. Now we have a second part for this problem. You remember what that is? Second part is, when half this work is done, what is the altitude of the rocket? What is the distance of the rocket from the surface of the earth? That is the second problem. So when half this work is done, half of this work is 1.63 times 10 to the power of 11, isn't it? Half of this, just divide this by 2. So half of this will be 1.63 times 10 to the 11 joules. When this is the work done, how far is the rocket from the surface of the earth? What all we need to do is put w equal to this value and then evaluate that integral one more time. Is that right? And find the value of that r. That's what we need to do. So we want to find the value of r when the work done equal to this. And you know, work done equal to integral re to infinity k over r squared dr. And that will be, here we are not going up to infinity. We are only going up to r, up to the altitude which we need to find. So we will replace that infinity by r, where k, we know this value of w. So w equal to integral re, the radius of the earth, to r, the altitude that you want to find, k over r squared dr. And the integral k over r squared dr will be negative k over r from lower limit, the radius of the earth, to upper limit r that we need to determine. And that will be, replace the upper limit, that will be negative k over r is replaced by r, minus negative k over RE. There you go. And you have now the two negatives make it positive. So you have 1.63 times 10 to the 11 equal to negative k over R plus k over RE. Now, do we know the value of k? Yes, we calculated the value of k earlier on. K is 2.16 times 10 to the 18, and the radius of the Earth, RE, is 6.64 times 10 to the 6 meter. And we know the work done, so we know this value, we know k, we know RE. The only unknown is the lowercase r. So that will be you can say that value minus this. See, if you notice, this value, move this k over RE to the left, k over RE. So that value minus k over RE equal to negative k over R. That's what this is. And simplify that. This will work out negative 1.63 times 10 to the 11 equal to 2.16 times 10 to the power of 18, that's your k, divided by R. Check this and see if this is right, the simplification of this. What all you need to do is take this as the common denominator and simplify the numerator, and then, or use your calculator. So you get negative 1.63 times 10 to the 11 equal to that quantity. Now the negative on the left, negative on the right will go. Therefore R equal to this quantity divided by that quantity. And that gives you 1.3 times 10 to the power of 7 meter, or it is about 13 million meters. When the rocket is about 13 million meters from the Earth, half the amount of work is done. That's the meaning of that. All right. Now, I want you to try this on your own. We have practiced a lot of exercises in this class for improper integral. Integral negative infinity to positive infinity, 1 over 1 plus x squared.